All right, guys, this unit is all about the periodic table. So we're going to learn about who made it and why it's arranged the way it is. So a long time ago, a Russian guy named Dmitry Mendeleev, so we're just going to remember his last name, was the first person to organize elements into a periodic table. He arranged it by atomic mass and also by chemical properties. There were a bunch of other people who came up with periodic tables, but he is the most popular one that started it out. Now later on, there were other discoveries made, and so eventually an Englishman named Henry Moseley updated the periodic table so it makes a little bit more sense. Instead of organizing it by mass, he organized it by the atomic number. Remember, this means protons. And also, he decided to keep what Mendeleev did and also put them in columns by properties. All right, so we're going to now learn the families of the periodic table. There are many, but we're going to concentrate on a main 4. Remember that group also means families. Families also means columns. So you got to remember that they are interchangeable. The first group that we are going to learn are called alkali metals. Alkali metals are very reactive. So the kind of picture that I like to draw is a very angry one because they are highly reactive. If you look on the periodic table, your alkali metals are sitting right here, except hydrogen. So we got to remember that hydrogen is not a metal. So lithium, sodium, potassium, rubidium, cesium, and francium are your alkali metals. And so if that is the case, we know that because it's in the first column, it has one valence electron. And so we're going to write that it has one valence electron. And we're going to draw a few examples of the Lewis dot structures. So there's lithium with one valence electron. We also have potassium with one valence electron. All right, and then what is another alkali metal that you see? We also have sodium with one valence electron. Perfect. The second family we're going to learn is called the alkaline earth metals. Alkaline earth. It's very easy to confuse group 2 with group 1 because they have very similar names. So be very careful that this ends with the in alkaline earth metal. They are pretty reactive as well, but not as reactive as your first column, your alkali metals. So we'll make him a little less angry, but he's still reactive. So if you look here, your alkaline earth metals are in the second column. All from beryllium to radium are your alkaline earth metals. They have 2 valence electrons. So if we drew some samples like magnesium, we would draw 2 Lewis dots. Same thing with calcium and barium. 1, 2. Perfect. The next family we're going to learn is in the 7th column. They're called halogens. Halogens are super reactive. They're just like alkali metals, but on the opposite side. So we're going to draw another really angry face because he is super reactive. So if you look on the periodic table, your halogens are over here, starting with fluorine, ending with astatine. So if we were going to draw Lewis structures, we say it has 7 valence electrons because it's in the 7th column. And then let's draw our Lewis dots. So you have fluorine with 1, 2, 3, 4, 5, 6, 7. Or chlorine, you can draw your dots however you want. You can start them wherever you like. So some people like to do it like this. So there's 1 dot there. And then there's bromine. You could do 1, 2, 3, 4, 5, 6, 7. Perfect. As long as it has 7 dots around your element. The last family we're going to learn are called the noble gases. They are super happy, super stable. They have no reactivity. They are what we call inert, meaning they have no reactivity. They sort of mind their own business. If we look at our periodic table, our noble gases are in the very last column. They start with helium and end with radon. So if we look here, they mostly have 8 valence electrons. There is helium, right? So if we look at helium really quick, helium is a little special because it only has 2 valence electrons. So 2 is still considered noble gas for helium. So I'm going to draw 1, 2, put a star here just so you remember that helium is special. But all the other noble gases will have 8. 2, 3, 4, 5, 6, 7, 8. And also argon. 1, 2, 3, 4, 5, 6, 7, 8. Whoop, there we go. All right, so those are your 4 families. Alkali, alkaline earth, halogens, and noble gas. All right, so let's talk about their physical and chemical properties. You don't have to know too much about them. Alkali metals are very soft and easy to cut. They do explode upon contact with water. So you watch a video about this. You'll see it in just a second. Alkaline earth metals are pretty close to alkali. They're just not as soft. They still react with water, but just not as much. Halogens are mostly gases, liquids, and solids. At room temperature, they can be gases, liquids, and solids. But what we notice is that halogens are always diatomic, meaning they come in pairs. So di means 2, atom means like your elements, right? So they always come in pairs. So every halogen, you'll see F, like fluorine, always comes in a pair. Like bromine will always come in a pair. Chlorine will always come in a pair, and so on and so forth. That's why they are called diatomic. Noble gases are odorless. They're also colorless. They're all gases. They do not react, and so we call them inert. So once again, there's that word again. Just be familiar with that phrase, inert, and then you will know all the properties. So these are the properties that you need to know about your 4 families.